Welcome back to BAPSI. We are moving on to another session of previous year question discussion of Kcet. Shall we move on to the first question? Here, the first question is C1C4 glycosidic bond is not found in which of the following? Actually, maltose, sucrose, lactose, and starch. In this question, we do know that sucrose is a disaccharide, right? So, the disaccharide which is found in here is sucrose. So, upon that, we might write the structure of sucrose. It is a 1,2 glycosidic linkage of a pentose sugar and a hexanose sugar. Okay. So, here we will go by this one. Sorry, this is the structure of sucrose. It is a disaccharide which is found with a C1C2 glycosidic linkage. So the correct option for this question is option number B, sucrose, right? We will move on to the next question. Hinsberg reagent is. Before moving on to this question, shall we discuss what is Hinsberg and what is the test used for this? Actually, we have studied in the amines chapter that when whether to determine the primary, secondary or tertiary amine, we used to treat with benzene sulfonyl chloride, right? Both primary and tertiary can be distinguished through this Hinsberg test. So, the correct option for this is option B, which is benzene disulfonyl chloride. Okay. Our next question is, which one of the following vitamins is not stored in adipose tissue, right? So, looking at these options, we could determine that vitamin A, D, E are water soluble vitamins, right? So, the only fat soluble vitamin that is found in this option is vitamin B6, which is stored in the adipose tissue. So, the correct option for this question is option B, vitamin B6, right? Our next question, which is prolonged exposure of chloroform in humans may cause damage to liver. It is due to the formation of the following compound, right? What do you think which might be the compound that is formed when chlorine? This is phosgene, which is COCl2. This is the phosgene that is formed in this given statement, right? This prolonged exposure to phosgene may cause severe skin damages and liver. So, the correct option for this question would be COCl2, right? Let's move on to our next question. Hypothyroidism is caused by the deficiency of which of these? Vitamin B12, adrenaline, thyroxine, glucocorticoid, right? Deficiency of thyroid, vitamin A, it is a hormone, deficiency of that hormone which is produced by the thyroid gland. Here the only hormone that is produced is thyroxine, right? Vitamin B12 is a vitamin, adrenaline is produced by when we are in a mode of something like a danger or excitement, we produce adrenaline. So, the correct option would be thyroxine, which is a hormone produced by the thyroid gland in which it causes hyperthyroidism, right? Moving on to our next question. The carbonyl carbon that does not undergo aldol condensation is, right? What is meant by an aldol condensation reaction? It is a reaction in which any carbonyl compound which does not have an alpha hydrogen atom, right? For this, what and all compounds do not have an aldol, which means an alpha hydrogen atom. Okay. For this, acetone does have an alpha hydrogen. Dichloroacetaldehyde does also have an alpha hydrogen atom. Trichloroacetate does not have an alpha hydrogen atom, right? Cl3, CCHO. This is trichloroacetaldehyde and this does not have an alpha hydrogen atom, thus trichloroacetaldehyde does not undergo aldol condensation reaction. So the correct option for question number this one is trichloroacetaldehyde, right? Acetaldehyde does undergo aldol condensation reaction due to the fact that it contains 3 alpha hydrogen atom. Okay, there are 3 alpha hydrogen atom present in acetaldehyde. Okay, we will move on to our next question. Which of the following has the lowest boiling point? Okay, what do you think? Which might be the which one of the following must have a lowest boiling point? Right. We do have an alcohol, 2 alcohols here, and an amine group and a keto group, right? We do know that alcohols form hydrogen bonding, intramolecular hydrogen bonding. So we could rule out the possibilities of option A and option D, right? A primary amine does have a higher boiling point compared to that of alcohols and carboxylic acid. So we could rule out the possibility of an amine, option B. Okay, the remaining option is an acetone. Okay, here, sorry, this is an ether, right? CH3O CH3. Okay, so here this ether cannot form hydrogen bonding with other molecules. There is no possibility of forming an intramolecular hydrogen bonding in any of these compounds. So this ether has the lowest boiling point. Due to the absence of an hydrogen bonding, it could be easily broken down. So ether has the lowest boiling point. Okay, so the correct option for this question would be option number C, which is an ether. Okay, moving on to our next question here. Give the IUPAC name of this compound, PTNH3 4 times PTCl4, right? So you do know the rules of naming an naming of a chemical compound according to the rules of IUPAC, right? So here, what do we have here? There is a neutral compound and an anionic compound, right? PTCl4 minus is an anionic compound with a negative charge. Okay, so we must find the oxidation state of the central metal atom, which is here is platinum, PT. On the first part of PTNH3 here ammonia is a neutral ligand, so platinum has a 0 oxidation state. You following up with me? Okay. And to the next one, platinum has an 2 oxidation state. Okay. Okay. Platinum on the second part has an oxidation state of 2. Okay. So the question is, the anionic part of this compound ends with 8, right? You studied on the IUPAC, anionic part ends with ATE. Okay, so platinum, we could write that there are 4 amines: tetramine, platinum 2, tetrachloride, platinate 2. So that is what? 8. The most important thing is that the anionic part of any compound, any coordination compound ends with the ATE. That's the important thing here. So the only option that has platinate is option number D. So the correct option for this question would be, option number D, which is tetramine platinum 2 chloride tetrachlorido platinate 2. Okay, are you following up with me? So the correct option would be option number D. Our next question is, function of potassium ethyl xanthate in froth flotation process is to make the ore what? Option A, lighter, hydrophilic, hydrophobic and heavier. Okay, we do know that potassium ethyl xanthate, okay, is a water repellent compound which is mainly used in the mining processes and all to repel out the water in the hydrated form. So the correct option would be a hydrophobic. Okay. It is mainly used, we have studied in the metallurgy part that this potassium ethyl xanthate is mainly used for the water repellent property. So, the answer for this question would be hydrophobic, right? Option number B. Okay. We will move on to our next question. Yes. Sulfide ore is on roasting gives a gas X. The gas X reacts with Cl2 in the presence of an activated charcoal to give Y. Y is, right? We do know that what sulfide ore. We can have any sulfide ore, right? We'll take copper sulfide. Okay, Cu2S. When the sulfide ore is roasted, okay, in presence of an oxygen, you do know what is roasting, right? Heating in the presence of an oxygen, okay, which gives what? Copper oxide, Cu2O, along with the sulfur dioxide, okay, sulfur dioxide. That's what here gives. This is the X, okay, X is sulfur dioxide, okay. When this X is reacts with the chlorine molecule, okay, when X is reacted with the chlorine molecule in what? In presence of an activated charcoal, okay, activated charcoal gives, we do know that X is SO2, sulfur dioxide, right? We get SO2Cl2. What do you name this compound? SO2Cl2, sulfyl chloride, okay, chloride, okay. So, the correct option would be option number A, SO2Cl2, okay. The Y, which is activated on treating with activated charcoal gives a Y. Y is sulfyl chloride, option number A. We will move on to our next question, which is, yes, an aqueous solution of salt A forms a dense white precipitate with barium chloride solution. The precipitate dissolves in dilute HCl to produce a gas B, which decolorizes acidified KMnO4 solution. Okay, we will come back to this first part of this question. What do you think that makes the decolorization of a KMnO4 solution? Okay, what do you think? What is a KMnO4? It's an oxidizing agent which is used in most of the oxidation reactions. So, here and decolorization of a KMnO, which means it turns purple to colorless. So, the given gas that is passed out is a reducing gas. Okay, so the only reducing gas we do have right here is sulfur dioxide. Okay, so we'll just try to make what is here. So we could rule out the other two possible options. So we are ruling out the possibilities of H2S. Okay, option B and C are removed. So we will move on to our first part. Okay, an aqueous solution of a salt A forms a dense white precipitate with a barium chloride solution. Okay, the only thing that might be formed is through sodium sulfate. Okay, BaCl2 along with Na2SO3. Okay, which gives BaSO3. Okay, this is the balanced chemical equation right down here. Plus what? 2NaCl. Okay. This is the chemical reaction of this one. Okay, this is A, compound A here, BaSO3. This BaSO3 when treated with the what? Hydrochloric acid. Here BaSO3 plus HCl, which gives what? Barium chloride plus SO2 and HCl, right? This is compound number B, which decolorizes KMnO4. Okay, this is sulfur dioxide. We do know that sulfur dioxide is a reducing gas. So the correct option for this question would be BaSO3 and SO2, which is option number A, right? Option number A. What I did here is I tried to rule out the possibilities of any other two options so that we could go back to the main options. So what I did here is I removed the non-reducing gases that are formed in the second part of this question. The only only reducing gas that can be formed through this reaction is sulfur dioxide. So I ruled out the possibilities of hydrogen sulfide, and both two are remaining, and by that I could find out what is the correct option, which is BaSO3 and SO2. We will move on to our next question. Yes, phosphorus pentachloride. What is phosphorus pentachloride? PCl5. Yes, one of the main compounds that we have studied in the phosphorus compounds, right? In our 11th classes chemistry text, we have studied many compounds of phosphorus, xenon, and much more p block elements. Okay, what do we have here? On hydrolysis gives an oxo acid of phosphorus which is tribasic. What is the only tribasic acid which is formed by the hydrolysis of PCl5? It is orthophosphoric acid, right? H3PO3. Okay. See, this orthophosphoric acid is a tribasic acid. What do you mean by a tribasic acid? A tribasic acid which only gives 3 hydrogen atoms on acidification, right? So here there are 3 hydrogen atoms on orthophosphoric acid which gives upon acidification. So the correct option, we'll look after the remaining options. Okay. H3PO4 on hydrolysis gives an oxo acid of phosphorus which is a good reducing agent. Okay. Here the oxidation state of phosphorus will be +5. Am I correct? Yes, give some oxidation state of +5. Here phosphorus is on the maximum oxidation state, cannot be reduced again. So the option B is wrong here. Has all 5 equivalent bonds. Is it true? No. This is because PCl5 has a trigonal bipyramidal in which chlorine are on the equivalent bonds which have same bonds. These 3 PCl bonds have same length, and the axial bond, both axial bond are different from that of equatorial bond. That means the axial bond is much more elongated than the equatorial bond. So the option C is wrong. Exists as an ionic solid in which cation has an octahedral structure and anion has a tetrahedral structure, right? It is completely wrong, as PCl5 cation has an tetrahedral structure and PCl5 anion has a octahedral structure. Okay. So the option here is absolutely vice versa, which means cation has an tetrahedral structure and anion has an octahedral structure. So the option D is also wrong, and the correct option would be option A, which is on hydrolysis of phosphorus pentachloride we get an oxo acid which is a orthophosphoric acid which is a tribasic acid. Okay. So option number A is the correct answer of phosphorus pentachloride. Well, we will move on to our next question. How many moles of acidified potassium dichromate is required to liberate 6 moles of iodine from an aqueous solution of I minus? Right. So before answering this question, we must have a balanced chemical equation of this reaction. Okay. Here potassium dichromate K2Cr2O7, okay, is when treated with potassium iodide, right, Ki, in an acidified solution, right, H2SO4, which gives K2SO4 plus 3I2 plus Cr2SO4 thrice plus H2O. Okay, let me just balance this equation. Okay, there are 6, 2, okay, 3I2, 6Ki, 7H2, okay, 0, 3, yes. Here we have a balanced chemical reaction of a treatment of potassium dichromate with potassium iodine. Okay. See, here we have said we are given that it has to be treated with I minus. We have taken here potassium iodide Ki, which gives I minus. Okay, that's why I written that. So here 1 mole of potassium dichromate requires which gives 3 moles of iodine. Okay. The question here is how many moles of acidified potassium dichromate is required to produce 6 moles of iodine. 1 moles of potassium dichromate required 3 moles. What about 6 moles of iodine, which gives 2 moles of potassium dichromate? Okay, so the option here would be option number A. Am I right? We require 2 moles of potassium dichromate, okay, to give 6 moles of iodine, right? We will move on to our next question. Number of stereoisomers exhibited by COEN twice Cl2 cation. Okay, so this is our compound. We do know that stereoisomers, we do know this is one of the most easiest question in the stereochemistry, determining the number of stereoisomers. Okay, so we should write about the cis and trans form of this compound. Okay, well, on writing this we have 2 types of cis structure for this compound. Okay, we'll write the central metal atom CO. Okay, we'll have this here En. Okay, En here. One second, let me just have a complete structure of this one. Okay, central metal atom cobalt. Okay, we do have En, ethylene diamine here, ethylene diamine here. Okay, 2 chlorine right about here. Okay, and the next cis form of this compound would be, we have one from here and one from here, right? And this chlorine molecule along here. These are the 2 cis structures of this compound, and the only trans structure, if this would be CO, En, En, Cl, Cl, right? Same compounds on the opposite direction, like this, right? So there are totally 3 stereoisomers for this compound. So the correct option would be option number D, right? 3 stereoisomers. We will move on to our next question, which is right. The coordination number of iron and cobalt in the complex ions. Okay, so these 2 are the complex ions here, right? What is an oxalate? This C2O4 is an oxalate ion, right? 2 minus is an oxalate ion. Oxalate ion is oxalate ion in a unidentate or a bidentate ligand. Yes, of course it's a bidentate ligand. There are 2 coordination centers to the central metal atom. Okay, so here there are 3 oxalate ion, which means coordination number of iron in this would be 6 into 3, 3 into 2, which is 6, right? It is a bidentate ligand. Oxalate ion is a bidentate ligand, and there are 3 oxalate ions which is coordinated to the central atom, which here is iron, through 6 coordination centers. Okay, So the correct option would be 6, which is coordination number for iron would be option 6, and we look after the what? SCN, thiocyanide, right? SCN, which is thiocyanide, which is a unidentate ligand, right? Unidentate ligand and an ambidentate ligand, which means it can both coordinate through two different centers at the same time on the same compound using two different centers, right? It could either coordinate through sulfur or a nitrogen atom, cyanide or thiocyanide. Okay, so it's an ambidentate but a unidentate ligand. So only one coordination number per ligand. In here it would be there are 4 thiocyanide into one coordination center, which means 4 coordination number. So the correct option would be 6 and 4, which is option number D. Am I right? Yes. The coordination number of iron and cobalt in the complex ion Fe trioxalate ion and cobalt tetrathiocyanate ion would be 6 and 4. Okay. We will move on to our next question. Yes. What is the incorrectly matched pair? Okay. What is the incorrectly matched pair around here? XeO3, which is a pyramidal, XeF4 is a tetrahedral, XeO4 a square pyramidal, XeF6 is a distorted octahedral, right? So let me just look at this here. XeO3, XeO3 is a sp3 hybridized orbital, so it would be what? A pyramidal, trigonal pyramidal. Okay, trigonal pyramidal. So that correct is an XeO3 is a correct option. We'll come after XeF4. Xenon hexafluoride, which is an sp3d hybridization, which have an distorted octahedral, which is also correct, and XeFOF4, which does have an what? Square pyramidal structure with the sp3d2. So XeOF4 is also, xenon oxyfluoride is also a correct answer. What about XeF4? Right, there are totally 4 bonding atoms and 2 lone pairs. So the correct structure for this would be XeF, okay, and which have an 2 lone pair on the both end. So this is a what? Square planar structure. So not a tetrahedral. So the correct option would be XeF4, which is tetrahedral, which is wrong. XeF4 has a square planar structure. Okay, XeOF4 does have a square pyramidal. This is because it has what? 4 bonded atoms and 1 lone pair. Right? It's actually like this one. Okay, this is correct. We will move on to our next question. Here, yes. Identify the set of paramagnetic ions among the following. Okay, so the most how do you find out the paramagnetic? Actually, we can do by calculating the number of electrons in the d orbital, right? Unshared pair of electrons contain what? Paramagnetic structure. Okay, we will discuss about that. We have vanadium 2 plus here. Okay, vanadium 2 plus, cobalt 2 plus, Ti 4 plus. Okay, V2 plus. Okay, vanadium, which has 4s2 3d3. 4s2 3d3, and upon removing 2 electrons, which gives 4s0 3d3. Okay, cobalt 2 plus, which also have 4s2 3d2. Okay, which removes 0, 0. Ti4 plus also have 0, no electrons. Okay. And here we do have what? Ti3 plus also have 1 electrons. Okay. So option number A is wrong. Okay. Option B. Ni2 plus. Okay. 4s2 3d8. 2 plus which gives 3d8. It's a paramagnetic, right? Sorry, diamagnetic. So option B is also wrong. Well, check out, we should find out which are the paramagnetic structures. Okay, if any one of it is diamagnetic, that whole option is wrong. So we do not have option A, we do not have option B. Okay, we do not need to check about Cu2 plus Zn2 plus. Okay, we will check out this SC, option D, SC3 plus. Okay, scandium 3 plus, right? 4s2 3d1 upon which removing of 3 electrons which get 4s0 3d0. So SC3 plus is diamagnetic, right? We could rule out the option D. Okay, so there is an easy way of determining the electronic configuration of D block elements. So I am gonna here to explain the first 10 elements of D block elements. Okay, we have scandium, titanium, vanadium, chromium, manganese, Fe, Cu, Ni, Cu, Zn. Okay, we have completed the first 10 elements of D block elements, which have 4s0, 3d1, 3d2, 3d3, 3d5, 3d5, 3d6, 3d7, 3d8, 3d10, 3d10. Okay, sorry, 3d10. Okay, there is an easy way of explaining this one, but you have to study this. So this is the electronic configuration of this compound. Okay, we have to find out but how much is Ti3 plus. Okay, Ti, which is 4s2 3d2. Ti3 plus gives how much? We get 4s0 3d1, which is a paramagnetic, right? Cu2 plus. Cu2 plus has 4s1 3d10. Removing 4s0 3d9, which is also paramagnetic. Mn2 plus. Okay, Mn2 plus. Mn2 plus has how much? 4s0 3d5, right? Which is also what? Paramagnetic structure. So it is an correct option would be option number C. All the 3 elements are in paramagnetic state. Okay, shall we check out the remaining one, whether it is a diamagnetic or paramagnetic? We could check V3 plus. Okay, vanadium 3 plus, which has 4s0 3d2, which is diamagnetic. Okay, so this is how we determine whether this is a paramagnetic or diamagnetic structure. We will move on to our next question. Okay, here, yes, the bond angle in pH4 plus is more than that of pH3, right? Have you ever heard of Drago's rule? You have to be familiar with this Drago's rule, right? Before answering this question, Drago's rule. Okay, in this rule, some elements which are hydrides of groups 15, 16th, okay, does not undergo hybridization, right? Like phosphorus hydride does not undergo hybridization. So here the pH3 molecule has no hybridization. It is due to the overlapping of p orbital and d orbital of these compounds. Okay, so what do we have here is that the bond angle in pH4 is more than that of pH3. This is because lone pair bond pair repulsion pH4 plus has square planar structure. That is wrong actually. pH3 has a trigonal structure. As there is no hybridization found in pH3 hydrides of phosphorus and its cation, we could rule out the possibilities of option B and option C. Okay. So the correct option would be what? Hybridization of P changes when pH3 is converted to pH4 plus. That is completely untrue, that as hydrides of phosphorus does not undergo hybridization. It is actually a structure formed by the lone pair bond pair repulsion. Okay. Yes, and pH4 plus has has higher bond pair lone pair repulsion than the phosphorus trihydride. So the correct option will be option number A. Okay. Moving to our next question. Yes. Copper is extracted from copper pyrites by thermal decomposition, reduction of coke, electrometallurgy, or auto reduction. You know, you have studied in metallurgy that the reduction of copper pyrites. Okay. Copper pyrites, what is copper pyrites? It's actually a sulfide ore. Okay. CuFe2S. This is copper pyrites. Do you get me? This is copper pyrites, in which this copper pyrites undergoes roasting, calcination, okay, calcination and smelting process, right, in a blast furnace. You have studied this in the metallurgy chapter about the reduction of copper pyrites to extract the copper metal from this ore. So here thermal decomposition is the wrong one. We do not thermal decompose. Reduction by coke, there is no application of carbon compounds or any other derivatives to this extraction. So option number B is also wrong. Electrometallurgy, that is also wrong. Actually it is an auto reduction of copper pyrites to copper metal. So the correct option would be option number D. Okay. Moving on to our next question. Yes. Cu2Cl2 and CuCl2 in aqueous medium. Okay. What is the correct option would be? These are all inorganic based questions. Okay. So you have to be much more thorough with the inorganic basics. Okay. You have to study about hydration, enthalpy, ionization to answer such types of question. Okay. This is out of box thinking question. So we might be giving that Cu2Cl2 and CuCl2, right? So in aqueous medium, they are asking about the stability of both of these compounds. Okay. And we have Cu2Cl2 and CuCl2. What is the oxidation state of Cu2Cl2? Which has 1 in Cu2Cl2. CuCl2 has oxidation state of 2, right? Oxidation state of 2. Okay. Yes. So on basis of this oxidation state, how could we explain the stability of such compounds? Okay. Have you ever heard of the term hydration enthalpy? Okay. Hydration enthalpy. See, more the hydration enthalpy will be the stable compound. Okay. Stable compound. How could we explain the hydration enthalpy along with the oxidation state? We could always say that smaller the size, larger will be the hydration enthalpy, more will be the stable. Okay. So in here, which is more smaller in size, Cu2 or Cu1? See, oxidation state of 1 or 2 is the smallest one here. Cu1 is much smaller than Cu2 plus. Okay. Actually here this Cl2 is option like has a +2 oxidation state, right? +2 oxidation state copper has lower size than +1 oxidation state. This is the fact that the attraction of outermost electrons. Okay. So Cu2 has lower, which means smaller in size, which have higher hydration enthalpy and higher the stability of atom. So Cu2 plus is stable. So the correct option for this question would be CuCl2 is more stable than Cu2Cl2. Okay, option number A. We have decided, we have completed that the hydration enthalpy regarding the stability. So CuCl2 is much more stable than CuCl. Okay, this is because when smaller the size, higher will be the hydration enthalpy, more will be the stability. So higher hydration enthalpy is directly proportional to the smaller size. So here the smallest size is Cu2 oxidation state. So the correct option would be option number A.